so many times I am saying that curl of grad phi equal to 0 vector or curl of grad f or grad phi equal to 0 vector. This you have to use in your MCQs. So now you have to know how these are coming. So curl of grad phi, let phi be any function of x, y, z. So grad phi will be I del phi del x plus j del phi del y plus k del phi del z. Okay, now if you want to know curl of grad phi, curl of grad f, anything, so curl of grad phi will be the determinant of I j k del del x del del y del del z, and what will be the first function? Del phi del x del phi del y del phi del z. So if you find the determinant, then this will be I, these two minus these two, so it will be del square phi del y del z minus del square phi del y del z plus or minus j with these two minus these two. So del square phi minus del x del z minus del square phi del x del z plus k cap with these two minus these two. So del square phi del x del y minus del square phi del x del y. So all these are cancel out. That is 0i plus 0j plus 0k. This is 0 vector. Again a similar question, that is curl of grad of f equal to 0, but the question is show that, and f xyz is given function. So again similarly try to solve this question. We can find grad f, that is I del del x plus j del del y plus k del del z with x square y plus 2xy plus z square, and this is, if you derive with respect to x, then 2xy plus 2y with I cap, plus if you derive with respect to y, then x square plus 2x j cap plus 2z k cap. Again find curl of this grad f, then determinant of I j k del del x del del y del del z 2xy plus 2y, the first function. Second function is x square plus 2x, and third function is 2z. So if we calculate this determinant, then I with these two minus these two, so this will be 0 because this is a function of z, and this is again 0 minus j cap, this is 0 minus this is again 0 plus k cap, this is 2x plus 2 minus again with respect to y, this will be 2x minus 2. So 0y plus 0j plus 0k, because 2x minus 2x and these two are cancel out, so 0 vector. That is curl of grad f equal to 0 always. And also you can write this note again, that curl of grad f equal to 0 vector. Now let's solve this question. Find the equation of tangent plane and normal line to the surface xyz equal to 4 at the point 1, 2, 2. So the solution, let us take the surface phi as xyz minus 4. Then first phi, the grad phi. Grad phi is equal to I del del x plus j del del y plus k del del z of phi, that is xyz minus 4, which is equal to, with respect to x, this will be yz I cap plus xz j cap plus xy k cap. And if we want to find value of this at the point 1 2 2, so just put the values. So 4i plus 2j plus 2k. That is, we also can write this as a tuple 4 2 2. For tangent plane, the formula for tangent plane at the point P x0 y0 z0 is x minus x0 del phi del x plus y minus y0 del phi del y plus z minus z0 del phi del z equal to 0. In this case, x0 y0 z0 is the point 1 2 2 and del phi del x at 1 2 2 is 4, del phi del y at 1 2 2 is 2 and del phi del z at 1 2 2 is 2. That is, ax minus x0 is 1 and del phi del x is 4 plus y minus y0 is 2, del phi del y is again from here 2 plus z minus z0 is z0 is 2, del phi del z at the point is 2 equal to 0. That is 4x plus 2y plus 2z equal to, if you calculate, minus 4 minus 4 minus 4. So that is 12. Hence you can take 2 common. So 2x plus y plus z equal to 6. Now formula for normal line, that is x minus x0 by del phi del x equal to y minus y0 by del phi del y and z minus z0 by del phi del z. So again we have to put the values, that is x minus 1 because x0 y0 z0 is the given point, that is 1 2 2 and del phi del x is again 4, del phi del y is 2 and del phi del z is 2 because at 1 2 2 the gradient is 4 to 2. So x minus 1 by 4 equals to y minus 2 by 2 and z minus 2 by 2. That is, if you cancel out 4 2 2 by 2, then x minus 1 by 2 equal to y minus 2 by 1, z minus 2 by 1. Next question is, find the directional derivative of fxyz equal to this one at the point 2 1 3 in direction I minus 2k. See carefully, no j is there. Let us start the solution. See, we know that if f is a given function at the point P xyz in the direction of this one, then the directional derivative is equals to grad f dot a cap, where a vector, where a vector is the unit vector in the direction of given I minus 2k. So we have to calculate first grad f, but at the point 2 1 3. So if grad f equal to I del del x plus j del del y plus k del del z f, and what is f? So I del del x plus j del del y plus k del del z, and f is 2x square plus 3y square plus z square is 4xi plus 6yj plus 2zk. Now we have to calculate at the given point is 2, 1, 3. So at this point grad f equal to 8i plus 6j plus 6k, and a will be, so a is what? A is unit vector in the direction of this. So a will be I minus 2k by square root of 1 square plus minus 2 square, that is 2 square. So I minus 2k by square root of 5. Now directional derivative is equals to grad f dot a vector, that is 8i plus 6j plus 6k dot product with I minus 2k by square root of 5. So 8 by root 5, j is not there, minus 12 by root 5, that is root 5 and minus 4 by root 5. Now next question, in what direction from the point 1, 1 minus 1 is the directional derivative of f x square minus 2y square plus 4z square a maximum, and what is the magnitude of the directional derivative? So solution, see, we need maximum directional derivative, and we know that the directional derivative is maximum along the normal to the level surface, and maximum value is equals to the modulus of grad phi. Since in what direction from the point, so it is given that maximum along the normal to the level surface, that is we have to calculate grad f, and this is the required direction in which the directional derivative will be maximum. So grad f at the point, so grad f is I del del x plus j del del y plus k del del z. F is x square minus 2y square plus 4z square, and if you calculate this, then this will be 2x I cap minus 4y j cap plus 8z k cap, and we have to calculate at the point 1, 1 minus 1. So grad f at 1, 1 minus 1 equals to 2 minus 4, sorry 2i minus 4j minus 8k, and this is the required direction from the point. This is the directional derivative maximum. So this is our required direction. And what is the magnitude of the directional derivative? So if the directional derivative is grad f dot a vector, where a vector is the unit vector in the direction given, so if we take modulus, then this will be only modulus of grad f, because this is unit vector. And what is mod of grad f? That is square root of 2 square plus 4 square plus 8 square. So this is 4 plus 16 plus 64, and that is equal to 20 plus 64, so 84.